Hi everyone, and welcome to our video on vector applications. So in these problems, what we want to do is draw a picture. We usually want to write our vectors in component form. So component form, they often give us these vectors in terms of magnitudes and volume, direction. So we would do our magnitude of v, cosine of theta, comma, magnitude of v, sine of theta. So there it is in component form. Oops, with a like that. There we are. Or you could do I and j in terms of I and j. When doing these problems, we always have SOHCAHTOA and Pythagorean's theorem to also help us. If it is a force problem, we would use Newton's third law. This first one, though, is a velocity problem, so we'll save Newton for later. All right, so let's see how these ones work. Well, let's read it. Read it very carefully. So it says a plane is flying north 45 degrees west at 500 miles per hour relative to the air. A 70 mile per hour wind at south 30 degrees west is currently present. Find the true velocity and direction of the plane. All right, so we're going to break down each of these statements. This one I'm going to do in the black ink. So we have our plane. Okay, so our plane I'm going to do as vector v, and we'll make a quick sketch. So north, east, south, west. Never eat soggy waffles. Okay, so we know we need the compass because of the north 45 degrees west. North 45 degrees west means start on the north and then go 45 degrees toward the west. Okay, so there's our vector representing the plane. And we know the magnitude of the plane already. The magnitude is 500. And we want the direction of the plane. The direction I'm going to mark in the pink. That's the standard angle. That looks like it should be just 90 degrees plus 45 degrees. And now I'm going to put it with my V right there. 90 plus 45 is 135 degrees. Okay, so that's our information for the plane. Now what we'll do is set it up in our component form. So our plane is V is equal to, component form is the magnitude 500 times cosine of 135 degrees, comma, 500 sine of 135 degrees. And then we'll go through and simplify. So we've got 500 times cosine of 135. Well, that is negative radical 2 over 2. Then we have got 500. Sine of 135 is positive radical 2 over 2. And then we'll simplify it. We've got negative 250 radical 2, comma, 250 radical 2. All right, so that's our vector for the plane. I'm going to just kind of cloud it. There we are. And then now we're going to do the one with the wind. So I'm going to do that one in blue. So it says a 70 mile per hour wind at south 30 degrees west is currently present. All right, so let's set that one up right here. I'm going to do it right underneath. Still never eat soggy waffles or sour watermelon. And we start on the south, and then we go 30 degrees toward the west. Okay, so that's the representation of the wind vector. So here's our wind. Let's do it as W. And we know the magnitude instantly is that 70 miles per hour. So we do know that part is 70. And to mark it again in pink, I know this is the angle that we want in standard position. This would be 60 degrees because 30 and 60 is 90. And then we know the straight line is 180. So it looks like our theta is 180 plus 60. So our theta, I'm just going to put it right next to my magnitude, would be 240 degrees. Okay, so those are the two pieces of information. And then now we could do our wind. Let's put it up a little higher. So our wind in component form is the magnitude, and then cosine of the angle, comma, magnitude, sine of the angle. So sine of 240. And then make sure I keep trying to do parentheses. There we go. The pointy pointy parenthesis is component form. And then we'll simplify. Okay, so this becomes 70 cosine of 240 is 70. Cosine of 240 is negative 1/2. 70 sine of 240 is negative radical 3 over 2. And then we'll simplify. So we've got the wind is negative 35 and negative 35 radical 3. There's the wind. I'm going to cloud it. Okay, so that's also important. And then the last thing, let's do that in green. Find the true velocity and direction of the plane. So to find the true velocity, and in a lot of these problems, let me scroll back up. So we want it in component form. And then usually all we do most of the time in these vector applications is we're going to add vectors together once we get them set up. So that's usually all that's required once it's set up. So our true velocity of the plane, so that relative to the air part means like the wind wasn't affecting it, and then now it's saying the wind is. That's what the true velocity is doing. Okay, so it's saying the wind is now either pushing on the plane or is a face wind, a headwind, or a tailwind, something like that. All right, so let's see what happens here. So what we'll do is add the two together. So our true velocity, let's put it right here. I'll probably need to go to the right column a little bit as well. But the true velocity I'm going to say is t, and it is the two vectors added together. And so for our true velocity, we've got the vector v, so negative 250 radical 2, comma, 250 radical 2, plus the vector w, negative 35, comma, negative 35 radical 3. And then we would add our like components. So the two x components, or horizontal components, add together. So we've got negative 250 radical 2, and then plus a negative 35, so minus 35, comma, 250 radical 2, plus a negative 35 radical 3, so that would be minus 35 radical 3. Okay, so this is our true velocity. I'm going to cloud it if we cannot use a calculator. Okay, but what I think we need is a calculator for these problems. So most of the time, they make us do our approximations. So there's Desmos. I'm going to use that. I'm going to do the scientific. And then I am just going to type those in to get decimal approximations. So negative 250 square root 2, and then minus 35. There's that number. And then I'm just going to copy and change that and put a square root of 3 on it. There we go, and there's that one. Okay, so those are our two decimal answers, the horizontal component and then the vertical component, ready to go. Okay, so let's, and I'm just double checking my signs, negative, negative, positive, negative. Okay, so good. So now let's write it as, so we'll put that right below, actually we'll put it up here. So now we're doing the calculator portion. I think I can fit it in this space. Negative 388 let's do one decimal, 0.6, comma, 292.9. Okay, so that would be, I'm going to box it for now. So that's our true velocity rounded using decimals in component form. All right, so what we will want, though, we'll need to convert it back to magnitude and direction. So let's go ahead and sketch what we currently have with this vector t. So negative 388 and then up 292, so something like that is where this vector is. And what we need is the magnitude of it. So I'm going to mark this with my magnitude of t. And I'm going to mark in this light purple. So I'm just showing we've got a right triangle. So we're about to use Pythagorean's theorem. So this to the left is the negative 388.6. And then this is the 292.9. And so we know the Pythagorean theorem would tell us how to get there. So we've got a squared plus b squared equals c squared, but c would be the magnitude of t squared. And then I'm just going to square root both sides. So often they do that in these problems. So I'm just kind of setting up the equation. Now, we don't need plus or minus. For habit, I think it's a good idea, but I'm instantly going to choose the positive. Okay, and so now we're going to write it as t, magnitude of t, is equal to our big old square root, the negative 388.6 squared plus the 292.9 squared. And then we need our calculator again, and that will give us, okay, so back to the calculator. There it is. I can see them both. Okay, so I'm just going to do a big old square root and get my parentheses ready, and I'm going to copy and paste these numbers. Okay, so I guess I could just type 2. Okay, so and I did round that to 6, and then squared plus, I think I could just type it in faster instead of copy and paste, so 292.9 squared. Okay, so there we go. So we have 486.6. So that is its new speed. That's its true velocity. So 486.6, and then that is the miles per hour. Okay, and so far, I mean, we can kind of check this number to make sure it makes sense. So notice our plane was going 500 before there was any wind present. And then a 70 mile per hour wind came. And in our pictures, the wind is pushing down on the plane as the plane is trying to go, I guess, or going pushing south while the plane is trying to go north. So it should slow it down. So this is a headwind. So it is slowing the plane down a bit. Okay, so just a little bit, but it is slowing it down. All right, so we do have the magnitude, and then the next thing that we need is the direction. So our direction, I'm going to label in, I'm kind of running low on colors. Let's do it in red. Okay, so I started doing it in green. This is the direction that we need to find. That's our theta. But then eventually they would want it to change into compass directions based on kind of the way that they are writing it here. Or maybe they do, maybe they don't. All right, but either way, we know that so we have a triangle, and we could just do our tangent of theta. Now, I used a and b in the Pythagorean theorem, but it really is the y over x. Our y is the 292.9. Our x is the negative 388.6. And so that will give us our answer. However, when we'll need to plug it into a calculator, so we need theta. We'll use our tangent inverse, and we'll plug those numbers in. This will give us one answer. We would want to make sure it makes sense. Now, right here, this is a negative number in the tangent inverse. So that means on our unit circle, where tangent is negative, should appear in quadrant 2 and quadrant 4. So we would want to choose the correct one. All right, so when we plug this in, so back to the calculator. Okay, so I've got my tangent of theta. Okay, so let me hit enter. Okay, so I need my second. There's tangent inverse, and it's in degrees already. So we'll plug in 292.9 divided by negative 388.6. And we get negative, we'll just say negative 37 since the 0.00 there. Okay, so negative 37 degrees. All right, so that's the angle that we got, but that's not really the angle we want. So there's the negative 37 degrees. That would be where this one is. Let's mark it on our unit circle. What's good about tangent is we know that these two answers are directly 180 degrees apart. So from here to here, all I would have to do is add 180 degrees. So that's what I really want to do. I need to add 180 degrees to this. That would be the angle that I really want. Okay, so if I do that, back to my calculator one more time. We've got our answer plus 180 is, we'll just say 143. Okay, so 143 degrees. And then that might be the final answer there. but they might want it in compass direction. So there's our magnitude. And I already have the direction there. All right, but it's in standard position, the direction that I gave. So they might want it in compass directions. Well, that's where, one more time on my drawing, it's small, so sorry, a little bit more room, but we know, so here I'm marking in the blue, we know that that's 90. And so I know the standard position would have started at the positive x-axis. So I know this in the blue is that 143 degrees. So I will just subtract 90 from it. Okay, so a little side work. The 143 minus 90 would make it to where we can get our angle in compass directions. Okay, so one more time. So 143 minus 90 is 53 degrees. Okay, so that 53 degrees is the angle that we want for our compass direction. So our final answer, let's kind of group them together. Okay, so we have that rope problem next to it, so it's kind of getting in the way. But we have the 486.6 miles per hour. And then the direction is north, and then it is going toward the west. So north, it's the subtraction that we did. Oops, I didn't write it. It was the 53 degrees. North 53 degrees toward the west. Okay, so there we go. Okay, and so just like before, we can kind of check that angle, the north 53 degrees west. So our original plane had a north 45 degrees west angle. This wind would be pushing down on the nose of the plane, so that would open the angle up that we currently have. It would be pushing it toward the west, and so yeah, that makes sense. So it's looking like it should be that angle. Okay, so long problem. Okay, so these vector problems, component form, add them up, and then reverse the order once you get the added component form with Pythagorean's theorem and tangent to help you out with the angle. Okay, so that's it for this problem. Okay, so a long one. Let's do this rope one in another video. Thank you for watching, and I'll see you again soon.